Hello, in this example we will learn how to use the boundary surface option. So, boundary surface is defined by the closed patches which define of curves which need to pierce each other and to define the closed boundary. In this case, we have this wireframe of whatever airplane model or whatever you want to call this speed form, which has obviously some cross sections, and then it has a curves which define it. And if we look, each of the section of this is closed, and actually each of the sections can be defined like a boundary patch surface. Boundary patch we can imagine like if we have really like a wireframe and you stretch some textile over it. To invoke the boundary patch command, we will go to an insert, surface, boundary surface, and now we have a direction 1 and direction 2. These directions does not refer to any particular coordinate axis. They just define, like we always have, like the curves going in a one direction and curves going kind of orthogonal to it, defining the patches. So, for a direction 1, also we need to start choosing the curves at the points closest to the curve definition. So, we start from the nose. Here is my first curve that I want to have. And I'm going to choose that sketch 1. And I choose it at the first point. Now, I will choose the sketch 2. I will choose the sketch 3, again at the end point, sketch 4, and sketch 5. As we go through, as you can see, it also gives us something which is called the none. And here is actually a directionality, or how we want that fabric to be stretched over. And obviously right now it is not stretched over anything defined. We need to put those guide curves on a side. Now, here is a problem that I have. That guide curve belongs to the one sketch. So what I will need to do, I will need to open, when I choose them, I will need to choose guide curve 1 and guide curve 2 as open segments of the sketch. So if I click on a direction 2, I will choose the open group 1, open group 2, and open group 3, 6, 7, and 8 curves. So how we choose them? We will click on the curve, and then I click on the open. This is a select open loop. So click on the icon, select open loop, click OK. Now do this on the opposite end, and you see as I choose that select open group, what happened. Now I will go on the other end. Again, select open group, click OK. And the last one that I'm going to choose, curve 6, 7, and curve 8. I'm going to choose. Curve 8 is which one? The curve 8 is actually defining the top profile. And again, open loop, curve 8. And here is my fully defined profile. Now, I can also specify some options and previews and curvature display. If I click on the options and previews, I can choose what I want, mesh tangent faces. And in a curvature display, if I click on a mesh preview, I can choose the mesh density. And here is now only like a 3 points per patch. I can increase, and look what happened. As I increase, look how much more segments I will put for the 12. So essentially now I have all of those little patches generated by choosing that mesh density, which will later on give me a better control on the surfaces, because those new, I can do something with those new faces. So, okay. And I'm going to click OK here. Click OK means this green button. Now, I have created my first mesh. Now I need to create the nose. And last time when we did a loft, we've seen that it is difficult to create kind of the nose dome-like structures. And we will see now how we are going to do it here. Actually, boundary surface is one of a very efficient way to close the loft or to create the nose dome structure by creating first a wireframe of how that nose of the airplane, boat, or whatever razor you want to look like, and then using those curves to create a surface, and then after solidify it, converting it to the solid. So if I zoom in to the tip of the nose, we can see that there are the 5 different, we have a 1, 2, 3, 4, 5, so there are a bunch of sketches here, and I'm going to insert a new one, and I'm going to choose as my direction 1 the cross section, and I'm going to choose the patch, and as a direction 2 I'm going to choose those curves which defines the curve 2 and 3, curve 4 and 5 actually. Okay, so if I go insert and I go insert surface and I use the boundary surface, direction 1 I'm going to choose my top, and I'm going to choose this guy here. Let me see, pardon, the curve 2 will be for the boundary, will be just the top end. And look what happened. As I choose those two, kind of close, but it did not follow up. The nose is not based on the definition. Now I need to choose in a direction tool. I need to choose my curves in the opposite direction, which will define my nose. Not my nose, I mean the nose of my model. Okay, this is the one curve. Again, open loop, choose the other side, the same curve, open loop, choose. And the last one, look what will happen now. As I choose the last one, you see that this is just the best fit. However, when I choose this curve, look how the surface is all scratched, how the surface is all stretched. And I will click OK. And here is my resulting boundary surfaces. And look, my airplane skin, they're very smooth, they're continuous, and here are my resulting boundary surface body. Boundary surfaces, actually we can do, then we can continue into the free form. In the next exercise, we will continue working on this model, and we will use the free form to actually induce some changes to this sketch defined boundary surface. So as a summary, the key is that the curves in a direction 1 and direction 2 should be in a opposite alignment or orthogonal or close to the orthogonal alignments. The curves should form the closed 3D contours. And when we choose the curve, if we have multiple curves in a single sketch, do not choose the entire sketch, but use the selection tool for the open contour and just choose the contour you need.